Hi, I'm Kathy Manley. This video covers Lesson 6, Drawing with Loops from Course E. The purpose of this video is to outline computational thinking concepts, powerful ideas, critical thinking skills, and pedagogical strategies to incorporate in the lesson, to model pedagogical strategies for implementing the lesson, and to review computational thinking concepts, powerful ideas, critical thinking skills, and pedagogical strategies addressed in the lesson. There are 3 lessons that we've asked you to do with your students this fall. Those include Lesson 3, Swimming Fish with Sprite Lab, Lesson 4, Hello World, and Lesson 6, Drawing with Loops that we'll cover today. There are some awesome additional lessons that you may want to do with your students, so we encourage you to explore the course. Computational thinking concepts are the concepts programmers engage with as they program. In this lesson, students will focus on sequence and loops as shown in bold. Powerful ideas are skills within a domain that change how we think or perceive the world and problem solve. The powerful ideas that operationalize computational thinking are also the computational practices that programmers develop when they engage with the computational concepts. In this lesson, we will focus on decomposition, pattern recognition, algorithm, and debugging as shown in bold. For more detailed information, you can rewatch the videos provided on our website. Students will also use additional critical thinking skills such as compare and contrast, cause and effect, predict, problem solving, plan, and observe. In this video, I will demonstrate this lesson and point out opportunities to use these pedagogical strategies to support student learning. We will use student-centered learning where students have time to play, think, and code, as well as direct instruction on key elements. We will also use the PRIM approach where students predict, run, investigate, modify, and make a program. Lastly, we will focus on the process of problem solving. Lesson 6 shifts from the Sprite Lab to the artist. Begins with a video that mentions data and programming for race car driving and provides a good introduction to the vocabulary students will need. Students learn how to use the algorithm to draw some basic shapes, and the idea of pixels and angles are introduced. After showing students the video, have students move on to puzzle 2. Typically, students are used to doing all the puzzles until they access another video. In this case, I encourage you to have students just try puzzle 2 so that you can have a conversation with them before they move on to puzzle 3. In puzzle 2, students are just learning to try out the blocks that are available to them because this is different from what they did with the Sprite Lab. So use the PRIM approach to investigate code. Encourage students to adjust the pixels and the angles to see what happens. They can string blocks together, try the repeat to create a loop to repeat a pattern. Once students have tried out some of these blocks, they can pull some over, click run. They could add additional blocks. They can move them from the workspace back into the toolbox and start over. Once they're done and you feel like they have a good idea of what's going on with the blocks, then have students share what they did, discuss some of the decisions they made, see if anybody actually made a shape or a pattern. Then they'll be ready to move on to puzzle 3. In puzzle 3, students have a specific task now to draw a square. So we want to focus on that problem solving. What is the goal? What is it that they need to accomplish? And 2 sides of the square have already been drawn. This is a good opportunity to really work in some collaborative pairs, especially as some of the shapes get a little more challenging. If the students are having trouble, encourage them to draw the square on paper and decompose the steps to consider what they did. When they finish, most students will follow a pattern of move, turn. So have a conversation. Was there only one way to solve this puzzle? And there are some creative ways that students might have used moving backwards or jumping. Did any students use the repeat? Did they see that pattern that maybe they could create a loop? You can even give them some extra time after this discussion to kind of try out some different ways that they might have been able to draw the square and practice again with those skills. After they've gotten some basics here, we're going to show them another video And this video is using those loops. So in the video, they explain the repeat block. However, the video doesn't really go into pattern recognition and only kind of mentions the word loop. So I encourage you to take a moment to discuss the repeated pattern that they saw in puzzle 3 and talk about how when a pattern repeats, programmers can add a loop to minimize the amount of code needed to complete all the steps in the task. You can even go back and use puzzle 3 as a demonstration. After showing this video, students can go on to the next set of puzzles. In puzzles 5 and 6, students will draw a square in puzzle 5 and a triangle in puzzle 6. In drawing the square, again, talk about their problem-solving strategy, have them make a plan and observe what happens. Do they see the repeated pattern that they can use to create a loop, and encourage them to try that repeat block to generate that loop. For puzzle 6, students are drawing a triangle. The angle in the triangle is shown as turning 120 degrees. It's already set in the block, but you may want to discuss why they use 120 degrees rather than 60 degrees, because students are familiar with the equiangular triangle having 60-degree angles. So it's a good opportunity for a math lesson. This is also a time to kind of talk to them about that loop and that problem solving, and maybe even talk about, what was similar or different from what they did in the square. When they get to puzzle 7, before students begin this lesson, really go through problem solving steps. What's the problem? Which is to draw a staircase. They need to develop a plan. So this is another really great place where you might have students draw the staircase on paper and decompose the steps to draw the staircase. Where do they recognize a pattern in their process, and how could they use that pattern to create a loop? Students will likely think about going right, down, right, down, right, down. Remind them that they might have to make some left turns and right turns if they're having trouble. Try to get them to investigate these things on their own first. Turning left or right is where they sometimes get stuck in finding that repeated pattern as well. So it's a good opportunity to also compare and contrast the steps that they thought they needed when they were looking at paper and what they're doing with their pencil when they're drawing a staircase compared to this computer program that they are now writing. The other thing, I'm going to go ahead and do this one for you because there's one trick that they sometimes find. So they're going to go forward, turn right, move forward, and turn left. And some of them will continue to do this, so we really want them to see that repeat. And they can move all of those steps into the repeat. But notice what happens when I click run. It says something's not quite right. And so students are going to have to do some debugging here and also really consider what it is that the program was asking them to do. This program asked them to trace that staircase so the black line is not as thick as the staircase. So a good opportunity to really talk about where in my workspace do I need to put a block that will widen that line. So there is a block here for set the width, and it can go right up here. Students may try to put it at the bottom. When then they click run, there's still going to be a problem because it's not setting the width ahead of time. So this is another opportunity. Really talk about sequencing. The width will be 20. They might have to try a couple of different times before they actually find the correct width. But it's an opportunity to talk about debugging, to talk about sequencing, and to really challenge those problem solving. So resist the temptation to tell them how to fix the problems and really encourage them to play with this, because that play, think, code is going to be really important for them as they start to work on projects on their own. Another thing you can do at this point is to compare and contrast the loops for the triangle, the square, and the staircase, and talk about, how do you determine those loops? Again, back to that problem solving, what was the task that you were trying to accomplish? Once they finish those puzzles, they go on to this set of puzzles where they can practice. There's a variety of activities here. For example, in puzzle A, it challenges the students with different angles and different pattern to recognize. Puzzle C will challenge them with some debugging. One thing I do want to note, if students click finish within puzzle 8, they will be taken directly to lesson 7, and we don't want them to do that yet. However, if they click on continue at the end of one of those activities, for example, if they work through all 4 activities and when they get done with D, if they click continue, then it will take them to where we want here at the end, these challenge activities. In the challenge activities, they have an opportunity to try creating this pet house, to draw a road, just a nice opportunity for them to, especially the students who may finish a little early, to try something different. The other thing they can do, you'll see down at the bottom, the start new projects. They have the Sprite Lab if they've been working on something that they could continue. And in the artist, it is a free play opportunity to do some drawing on their own. These can be accessed at home in after school setting, after completing classroom activities. They're really available for students to come back to on their own. It doesn't have to be part of a class activity. When they're done with this, go ahead and wrap it up with them. What did they learn? What did they do when something didn't work the way they expected? Reinforce that idea of debugging. Compare and contrast this lesson to the lessons they did using sprites. Talk about, was there more than one way to accomplish each puzzle's goal? They saw some patterns. They had that pattern recognition led to some looping using that repeat block. Maybe even talk about what's the advantage of using those loops. Is there a time when they may decide not to use the loop? For example, if they only need to repeat the pattern twice, it may be just as easy to just continue the pattern. But if it's a very long pattern that they want to repeat twice, they may recognize that the loop is more beneficial. And then how important was sequencing in these activities? We talked about when to put in the width, but what would happen if they changed the order of the steps in the staircase activity? And maybe try that with them and see what might happen. So the other thing I wanted to point out here is if we go to the lesson plan for this activity and scroll to the bottom, there is a cross-curricular activity here called the Land of Geometry. And you can see the standards assessed that are both math standards as well as ELA standards. And if you click on that Land of Geometry activity, it really walks you through, it has resources for you, and it has them working with the geometry to create this land of geometry, but then also writing an opinion piece supporting why that land of geometry should be the one that would be the best place for the artist to live. Let's take a moment to debrief. We covered several computational thinking concepts and powerful ideas that align with this lesson. When developing the staircase, reordering the steps might change the direction of staircase, and taking a look at where to put that width block made a difference in the sequence in which the program needs to be written. Students explored repeated patterns in the shapes in order to create loops of code within the algorithms. Students used decomposition when they worked through the steps to solve the problem, such as drawing the staircase. Students decompose when they consider the problem or goal for their program, plan the steps, and write the code. When the program didn't run as expected, students worked to debug their programs. We also applied critical thinking skills by having students compare and contrast sprites and objects in other games they've played in the artist versus the sprite program. Observe the cause and effect, what happens when they click on run. Making predictions, solve problems, making a plan, and observing the code. We also employed a variety of pedagogical strategies by encouraging students to play, think, and code while providing direct instruction for key elements. Students also focused on understanding the problems, devising solutions, and using the PRIM approach to investigate and make their programs. When you're working with students, it can be helpful to reinforce the vocabulary, especially in other classroom activities, to reinforce the skills they're learning. We encourage you to address additional computational thinking concepts and powerful ideas whenever the opportunity arises. Thank you for watching this video.